All right, hello everyone. I know we're still waiting for some people to come back from lunch, but just in the interest of time, I'm going to move us into our paper presentation section. I know. Thank you. Okay, so this afternoon we will have 5 paper presentations, followed by a short coffee break, and then another themed session on computational reproducibility. I will kick us off by introducing our first speaker, who will be Linnea Gandhi. She is a lecturer and PhD candidate at Wharton, where she studies metascience, research infrastructure, and behavior change. Prior to Wharton, she taught as an adjunct professor at Chicago Booth and ran a consulting firm specializing in applied psychology and experimentation. So please welcome Linnea.
Hello, everybody. Thank you for showing up on time. You're the good ones, right? Don't tell them. I'll just wait for the slides. All right. So I have to say I was a little bit nervous about being the speaker that happened right after lunch, food coma and all that. But it turns out it is a really good opportunity to start our talk today with a question. Bated breath. Am I hitting the right button? Hey, did you choose a healthy lunch today? Did you fill up your plate with salad, with chicken, or just baklava? We had some choices today. Did you choose to eat healthy? We could also ask whether the organizers of BITS maybe wanted to encourage us to choose healthy. And if they had wanted to encourage us to choose something healthy from the options they gave us, what could they have done? Well, they could have done something like nudge us. Nudge is a concept from the field of behavioral science that has become pretty popular over the past decade, and its formal definition is on the slide here. It's any aspect of the choice architecture that alters people's behavior in a predictable way. So for us today, eating lunch, that would have been the experience of standing in a queue, looking at those options, how they're displayed, what order were they put in, were there any signs describing these options? All of that is the choice architecture of that situation. And the organizers could have chosen to change one or more of those elements to nudge us perhaps towards more salad and less baklava. Some examples of what they could have done. Well, this is from the recent literature. They could have used smaller plates, maybe oval size rather than those circles. They could have only put out the salad and vegetarian options such that we had to ask if we wanted the chicken or the salmon. Or they could have put down evaluative labels. So smiley faces on the salad, unhappy faces, and thumbs down on that baklava at the end. These are all legitimate nudges they could have done, but we know Grace and Iman, you were running around all week, right? You didn't have time to read the literature and put something together around this. So yeah, right, exactly. So you would have wanted to know, well, just tell me which nudge works best, and I'll do it. This question, which nudge works best, I have heard over and over and over again in my career prior to coming to Wharton. I was in the field of applied behavioral science, consulting to companies across many different industries about how they could use nudges to improve the behaviors of their employees and their customers. And every single client wanted to know, well, just tell me which nudge works best. And the conversation would go something like this. Well, I'd say it depends. And they would ask on what? I'd say it's, well, the behavior, the context, the geography, the population, all of these different attributes that we talked about this morning. It depends on all of those. And they would press me and say, look, we're paying you a lot of money. Just tell me, from my context, what do I do? And on every project, I would spend hours, days, weeks looking at the literature, trying to find an answer to this question, talking to my friends in academia to get their advice. And at the end of the day, I just kept coming up short. I just didn't know what nudge worked best. Every study I read was fascinating, interesting, and maybe even all of them very well run. But they used different nudges across different contexts, and putting them together in any cohesive way to come up with a prediction for this context, it was out of the question. And so the conversation would typically end with, well, look, I don't know. Here are my best guesses. We're going to have to run an experiment. I'm not the only one having this conversation. For this project that I'm sharing with you today, We've interviewed lots of practitioners across the worlds of government, policymaking, nonprofits, industry, and all of these behavioral science practitioners have this same conversation, this same issue in their projects, where they can't come up with a good prediction from the literature, and they advocate for experimentation in every single new context they're in. The disappointing thing about this is that when we do run those experiments, the effects end up being much smaller on average than what we find in the literature that they may be mimicking. And more so, there are often a lot of null results that we don't often report, partly to what was discussed this morning. And this all presumes that you can run an experiment in the first place, which is really not the case in many real-world organizations interested in using the insights developed from this field of nudging. And so the problem that we're dealing with, the way I see it, is that we just don't know what we know. We have hundreds, if not thousands, of nudge studies today from the past decade of literature producing them. Each one is interesting, but when we look across all of them, we actually can't put it together in a cohesive way that's helpful to practitioners or even academics wanting to run field studies. And while the focus of this talk will be on this problem in the nudge space, I do want to mention in our lab at Wharton, we suspect this is a problem across other areas of social science as well. So we have a sister project around the tasks in team space that looks into this as well. And it's possible this might even exist in the so-called harder sciences. It feels like every other day I'm either supposed to drink a lot less red wine or a lot more red wine. And I just don't know what the answer is because it seems to depend on which study I read. So this talk is going to focus on the problem of why we don't know what we know and what we can do about it. And I'll cover it in 3 different sections. First, I'm going to suggest to you why we have this problem, at least in the field of behavioral science, which is the one I know best. I'm then going to propose a high-level solution that we're working on in our lab at Wharton. And then, especially as this is a very practice-oriented group, I'm going to open the hood and have you see a little bit of the guts underneath the project to talk about how we're operationalizing it. And so let's start with the why. And again, this is very focused on the field of psychology and behavioral science, which is what I know best. Why don't we know what we know? Well, about 10-ish years ago, a lot of the answer to this question centered around concerns with replication, replicability. We would have a study that's been run. When we run it again, we don't see the same effect, and we start to doubt the reliability of the literature. So in our example today with lunch, maybe our organizers, Grace and Imam, had decided to do that labeling nudge that I suggested. And we run it as an experiment, we get the data, they tell us at the end of the conference, it didn't work. Well, what happened? Maybe the original study was a false positive. Maybe our study was a false negative. It's not a reliable effect, we can't trust it, we don't know what we know. In the last 5 years, again, in my field, this discussion has really shifted more towards generalizability. It's not that these effects can't be trusted, that they're not reliable, it's that they don't generalize to a new population or a new setting or a new context. Again, many of the themes that we heard about this morning. And so if we didn't end up getting an effect from that great experiment Grace and Imam ran on us, well, maybe it's because we have a different population. You're all generally from California. You're all really healthy. No nudge is going to get you to eat a little bit less baklava, a little bit more salad. You're already doing well. Or maybe we instantiated that nudge slightly differently. Maybe instead of using thumbs up and thumbs down, they decided to do color-coded emoji symbols, and this effect was very sensitive to those thumbs going up and down. Or perhaps it was the dependent variable we used. In the original study, they looked at total calories consumed, whereas maybe in this study, they were measuring whether we ate vegetarian or not, a binary variable, so very different statistically and substantively. Any of these reasons could be why it didn't generalize, and we're back to our question of it depends. What I want to propose to you is that the discussion shouldn't end here. This is not the last why explaining why we might not know what we know. There's another why behind it, which is commensurability, comparability of effects across the evidence base that we have already. We have no hope, in my opinion, of getting to generalizability if we can't compare studies in the first place, use the same language for describing the population, the intervention, the dependent variables involved. And right now, for better or for worse, there's massive research or degrees of freedom in the choices being made, how they're articulated, and whether they're even articulated in the first place. And so what our lab wants to propose is more of a focus on commensurability in order to enable generalization across a knowledge space. And that comes down to trying to build a shared language to know what we know. Let me give you an example of what I mean, though, by lack of commensurability or lack of comparability from this space. And to do that, I'm going to start with a really simple concept or construct. If I have a nudge experiment, I could tell you what the topic of that experiment is. Is it about the environment? Is it about healthy eating? Is it about something in finance, right? The topic, the domain of an experiment. Across the bottom of this slide here, you'll see 6 different author team names. These are all citations, different studies that are mostly systematic reviews or meta-analyses historically in the nudge space. And each one of these teams talks about the topics of those nudge experiments. Are they finance? Are they environment? Are they health, etc.? I'm going to take 50 new experiments. These are actually in our database in this project, 50 new nudge experiments, and I'm going to code them using the language used by each of these research teams, just by the topic of these experiments, and I'll show you what it looks like. So first, I'll just show you those 50 new nudge experiments coded by the topic categories used by Mertens et al. So if you look at this, I know the font is small, the bulk of them are in finance. Okay, so that might be the inference I come away with. In this set of studies, they're mostly finance, or at least that's the plurality. Let me show you the exact same 50 experiments coded across the 5 other languages describing topics. It's all over the place. And this is not a critique of these underlying studies. These are great, well-run studies, but they are all using different articulations of topics, domain settings that fit their sample. But when you go out of sample with a new set of studies, it ends up demonstrating a little bit of a mess. Depending on which of these languages I use, which of these coding schemas I use, I might come up with a different inference about the exact same evidence base. This is what we mean when we say lack of commensurability, lack of comparability. And if we can't solve this with a simple concept like topic or domain, what chance do we have for something like mechanism of action, psychological concept, nudging? We don't have a chance. So we really need to start working, we think, about getting to this shared language. And to do that, we propose a methodology called research cartography, how to build a map of what we know. This idea comes very much from the realm of geographical cartography, mapping an actual geographical space, and I'll pull that through as we go through it. It happens right now in 3 high-level steps. The first step is to define the knowledge space that you care about. So if we're thinking about geography, that might be the Earth. I care about the Earth, or I care about North America. You define the bounds of the knowledge space. In our world with behavioral science, we are looking at the question, which nudges work, for whom, and under which conditions. The second step is to define the coordinates of that space, the dimensions or the language for describing that space. And this is the key step. This is our longitude and latitude in geographical terms, but pulled into the terms of the knowledge space. For us, there is a long list of these that I'll go into in the next slide, but we're including demographics, different ways of talking about domain, timing, different theories. Notably, different theories are covered here. We're not a-theoretical, but we're a bit theory agnostic in how we're coding the space. And then finally, we want to populate that space with data. So we're starting with the last 5 years of experiments and hope to add more over time. And we're also adding new experiments where we think they will optimize learning from the space, either from the lab or the field. Ideally, someday, probably many years from now, we get to a point where this knowledge space is as rich as what we see on Google Maps, where I can find, just like in Google Maps, the distance between 2 studies by the correlative by foot, by train, by car. Whatever your goal is, we're looking at the same knowledge space. We should be able to use the same infrastructure around it to answer those questions. Now, we build on a lot of great methods that are being used today and improved over and over, and so we're looking at those as well. One of the questions you might have, especially those in this audience, is how are we different from the systematic reviews and meta-analysis space? And those of you who study meta-analysis can correct me after if I'm getting it wrong. But the way I like to think about it, the short answer is that these past methods are often about summarization, description of an existing set of knowledge. Research cartography is trying to map that underlying set of knowledge to provide the coordinates for navigating it, and hopefully generalizing better and even predicting out of sample with it. So in the Google Maps analogy, you might think of these past methods is giving you a really good estimate of how long it's going to take by plane to travel between Boston and San Francisco, whereas research cartography is trying to generate and organize the data underlying Google Maps. So you could answer that question for any two pairs of cities, including cities that don't yet have historical flight data. That's the aspiration. In order to do this, the most critical step is that second one. And we really touched on that a little bit this morning with the first panel. How do you define the dimensions of that space? That's a really critical step. And so I'll show a little bit about our philosophy, at least in approaching it. I'm happy to talk offline about the details. And to do this, I'll go back to the why. Why are we doing this in the first place? What's the root issue at hand? And we believe to get to generalizability, we need commensurability. We need a language for saying what generalizes. And so to do that, we turn our chevrons on our head and go back to saying, what does generalizability even mean to begin with? And there's a nice framework we're borrowing right now from Finley et al. That gives us different categories of generalizability listed here at the top. And so we're currently organizing the dimension of the space across each one of these categories, including two others that we've added around the experimental design and features around open science, which we think might be important for looking at the knowledge space. So right now, to be honest, we've got 250 dimensions and counting. And this has been going on, the pure coding part of this has started in September. So this is from about 6 months of work. And I have to say, we add dimensions every week. So it's a very wide potential data table we're trying to build. How did we get to 250 dimensions? Well, it goes back to the philosophy of how we're approaching this. We don't want to dictate the language that everybody is using. That's not feasible, certainly not me. Who am I, right? A PhD student to tell you what to do in coding a study? So we're trying to unify all of them, to translate across them. And that's how this data table becomes so darn wide. So I'll show you an example. All 6 of those different ways of talking about topic or domain, we're including those. Or all the different ways you can talk about a nudge. There's many frameworks, many categorizations out there. We're trying to include all of them. Right now, we starting with 10, and right now that's 107 dimensions on its own. And then a little bit, as our keynote speaker mentioned prior to lunch, even with the single experiment, there are many ways to articulate the results and report estimates. We're trying to include all of them. And so you can see how these columns, these dimensions add up pretty darn quickly in the database. Beyond thinking about that second step, I do want to spend a few minutes to show you the guts of how we put all this together in a pipeline and infrastructure inside the lab. And so let's look a little bit under the hood for all 3 of these steps together. At the end of the day, we're trying to get at this living database of commensurable experiments. That is our North Star. To do that, we start with a pipeline of past evidence, much like you would in a systematic review. Ours is coming from a mix of evidence from academics, as well as from practitioner partners who publish their work or are sharing their data with us. Those go through a pretty strict inclusion criteria process to get us to a set of experiments that are ready to code. They have to be experiments, they have to be on nudging or choice architecture more broadly, and they have to be on a real behavior, at least to begin with. Those then get extracted for their core dimensions by our team. These are generally more objective, although everything is subjective as we're learning in this process, but this is about like the conditions, the behavior, the setup of the experiment. And then we have 2 auxiliary processes of coding that happen on top of that. One is with a trained set of experts around nudging and choice architecture, as they will look at the different conditions of the study and attribute it across all of those different typologies of nudges. And then we have a process for coding behavioral dimensions, which can be a little bit more subjective, like how easy a behavior is might differ depending on who is coding it. Those go back to enrich the database. And then, perhaps the most exciting part is that we're adding new experiments in the lab or field to enrich the database where there isn't much evidence to date. The unit costs of this, I think, are quite exciting to look at. It costs about 4 to 5 hours to code a single experiment. No, that's not a paper. That's an experiment inside a paper. It's extremely labor intensive right now. And one of the things I'll ask you about is there a way to lower this unit cost? You might also wonder then, is this worth it? That's a lot of labor. It's going to take a long time to do. And I think it is. And if we got to come back to that first conversation that I started with to really remember that. If all we know as a practitioner or an academic is it depends, I don't think we know enough. I don't think we should be satisfied with the knowledge that we're producing. right now, often when we run these experiments, we're producing them one at a time, right? In some theoretical space that we can't see. And then when somebody wants to make an inference about that space, they're kind of waving their arms, trying to classify it, and coming up with a way of talking about these differences that isn't necessarily quantifiable or reproducible. What research cartography is trying to do is uncover those hidden dimensions that actually quantifiably describe how different or how similar two experiments are when looking at the literature. So here, for example, how pro-social is the behavior, or how many interactions are happening in that nudge condition. And as you add more and more experiments, the hope is that we start to make sense of this knowledge space such that we can talk about what is working and what isn't working for different populations, different settings, etc. It's really trying to get at truly cumulative science that bridges the boundaries between academia and practice so that we don't have to settle for it depends, but we can actually start saying, well, look, let's take an actual prediction from the map of the evidence that we have to date. And if we run an experiment, we get to test how well we know what we know. That's what we're aiming to do. And there's actually 3 different things you can do once this database is more built out. You can exploit it, which is what I mentioned on the prior slide, which is to find and make a prediction about a new space. You can look at areas to explore that are white space, and you can evolve the database. If you find 2 experiments in the same point in the map, and you see that they look the same, but their results are different, you might realize that you're missing a dimension, and we're able to evolve it over time. So really what we're trying to aim for here is a public good beyond any paper itself for communities to use to understand what we know. And I saw my time check here, so I'll show you just quickly. That's an illustration. This is actual data. We are doing actual data, just very slowly behind it. And a few lessons learned and current challenges. I will just say the one I'll focus on is just every paper is an exception. Every time I think I built a coding process that works, I break it because I find yet another experiment that has a different dimension or a different way of looking at things that I just didn't anticipate. And so it's been frustrating, very humbling, and we've had to build quite flexible infrastructure to tackle it. And I'll skip over this just for time and say, if you remember nothing, I hope you start asking yourself, how can we know what we know in any field if we cannot reliably compare different sources of evidence? I don't think we can. More succinctly, cumulative science requires commensurability, and we're trying to solve that with research cartography so that all of us can start to better explore, exploit, and evolve the space of what we know. And I want to thank you for your time and the awesome team behind this project. So thank you. Oh yeah, I'm not sure if we have time for questions because I saw your timekeeping. We have 5 minutes. Oh, I thought I saw a 90-second mark there.
And then you have 5 minutes.
Oh, wow. Okay. Well,
Unless you don't.
I mean, no, it's fine. I would love, I'm delighted. Yes. If you have any questions, suggestions, complaints, compliments, I will take them.
Hi, thank you for that. So when you build a public good, which is this massive repository of interventions, I think one question to ensure that this goes on is how do you think about incentivizing researchers to actually carry on with it and to actually fill this repository out when a study is published?
I really would love an answer to that question. You have an answer for it? Go for it.
We're building a similar thing in a completely different field, but what we've designed is after you finish your form, you make an available form that people could fill out. Doesn't mean they will. We're still going to be monitoring and doing it ourselves. What we want to recommend is sort of a type of reporting guideline is a form that these fields sort of check it. And if your resource becomes the main one for the nudge, theory and experiments, then I think people will have to reference it whenever your first paper comes out. And then this is the way for them to think about all of these dimensions when they're reporting their study. And I think, it is the hope then the young researchers will learn from that. But the form of what the fields are and how they could be filled for a single study is what I'd recommend for you to do.
Well, there we go. That made my job easy. But fill out a form, make it easy. Yeah, I think it'll be hard to get uptake, to be honest. This is not fun work to do. I find it intellectually fun, but coding is long and tedious. Reporting all your dimensions is long and tedious. And so while I'm hopeful that this is going towards a solution, I think it's going to be a decade, to be completely honest, to do it. But there's hope, right? If we think about geographical maps, when did we actually get our first world map? 1450. by a monk, like several monks, right, in Italy, with some Medici style people sponsoring them. So right now that's us, right? We're in the 1450s with knowledge. We got to deal with it. It's a bad map. What we produce will probably be pretty crappy. Excuse my language, right? It's not going to be good, but we're setting the stage for maps to get better and better and better. And eventually we will get to the Google Maps, probably with a little bit more technology than just the human labor we're doing today.
Yeah, thank you. This is fascinating. In addition to talking more about reporting guidelines later on, here basically you are learning a lot about the variation of how papers report what they do and what they don't, and the context and all the important information we were talking in the morning. Have you already, or is it in your plans to release some type of guidance for future papers on how to report some basic information?
I shy from the word guidance because I don't feel like I have a platform to stand on to tell you this is how you should do it. I mean, I'm not an expert in all the methods I'm reading. I'm learning every time I do. I want to just make the point that we're not disclosing enough. And if I have to reach out to every single author team for every single detail that might be important, that's a problem. So I think trying to raise awareness around that and then doing the grunt work that no one else wants to do, at least for the time being, is what I'm thinking. Maybe it will evolve to guidelines. We'll see.
So I understand this question is sort of irrelevant unless the maps actually get built and they work. But one of the themes of this morning was how transparency kind of both enables people to look at the quality of studies, but also sort of opens this black box of people maybe overanalyzing it or trying to undermine studies. How does sort of quality play into these maps, right? So you can kind of compare the similarity of studies on these different dimensions, but like, how does that sort of relate to a lot of the themes of this morning?
Sorry, can you repeat the thing you said about quality?
So like, how does, you can map out all of the various dimensions of these studies, but that doesn't necessarily tell you how well the studies were implemented.
Yes, so I take a lot of inspiration from work by Yuri Simonson and team on this right now. They've got a bunch of data Cloud posts and a recent piece on it. We are filtering for quality as we can best judge, and we've been coding what we mean by quality along the way. But I think at the end of the day, you're making a judgment, right? Who am I to say what's high quality? I can do my best, but you might have a different decision. So I think you have to be entirely transparent about that, and maybe someone will do it better. So I like, for instance, we are looking at elements of internal validity, but we're also looking to say, are your materials even available? Is your data available? Is this a hypothetical versus a real study? Things like that.
I just have a quick question. That was so fascinating. I wonder if thinking about the future and how to sustain this kind of effort, if collecting 250 dimensions wouldn't be sustainable, but if there were, 20, it would be. And have you guys thought through a process for narrowing down? So for instance, if you're regressing treatment effects or trying to predict treatment effects, you could use machine learning tools or other kinds of tools to figure out which of the 250 dimensions most consistently have predictive power. And maybe you start big, but over time you narrow down and you've learned, hey, these 10 or 15 dimensions really have predictive power. And then we do try to promote reporting on those dimensions. It does feel like you're doing an incredible service with this public good. It's so exciting, but maybe it's backbreaking to continue collecting 250 or 300 dimensions sort of on every study forever.
Yes. And I mean, since a lot of them come from different classifications of the same theoretical concepts, they're correlated, right? Those different domains from different authors, are they really going to be ones we want to sustain over time? Right now, I think they're useful for showing people we're trying to translate across their mental models, but eventually I could imagine dropping 5 of the 6 or developing a superimposed set that contains more of a mutually exclusive and comprehensively exhaustible set. So I do think a lot will drop, and quite a few are empty when it comes to the results section because people are only choosing 2 or 3 methods at most, and then all those other columns are blank. All right, thank you for your time.